Good morning. I'm Dr. Zafarullah Qureshi, Professor, AI University, and in the next 3 minutes, because these things take so much space, I'm going to introduce a series of talks that I've recorded for you in these holidays due to coronavirus. So basically, I'm going to talk about three important formulations in n-particle transport. N-particle means neutral particles, charged particles, ions, electrons. So basically, how do you model the transport of particles to find out information on them? Okay, so this is my name. That's my website, www.nucleareng.com. And this is the first of a series of, I think, 4 or 5 lectures, 3 minutes each. So I'll be talking about three important formulations. Now, what are those? First is the diffusion equation. Second is the transport equation. And third is the integral equation. And these are all forms of the Boltzmann transport equation. Ludwig Boltzmann was a fascinating scientist who first formulated transport for the kinetic theory of gases, and 1844 to I think 1907, Austria. So basically, since this is all nuclear atomic, so let's go a little bit the background. Now, it was in the 1920s that Rutherford at Cambridge University made a picture of the atom. Now, the atom is something like this. It's got a home and it's got electrons going around it. It's got a dense nucleus and things. So this was a picture of the atom which Rutherford and scientists before him made. But they did not know of the neutron. They just knew there was a proton inside and there are electrons outside. Now, it was in 1932 that Chadwick at Cambridge, same labs, Cavendish labs, repeated a number of experiments which were carried out in France and Germany, basically firing alpha particles from polonium. Polonium is a heavy material, firing this on beryllium, and basically they found something coming out of it. So in France and Germany, they were not sure what it was, and they thought it was something like a proton or something, some gamma coming out of some nucleus. But it was Chadwick who was first able to show that no, it's not a proton. In fact, he put some wax over here, which is a hydrocarbon, and so basically there was a lot of energy transfer, and he measured the range of the protons here. So in 1932, he discovered the neutron, and he got his Nobel Prize for this. Now, 1933, Fermi started his work, and he showed that because of, well, it's about 3 minutes, so I think I'll stop over here. So Fermi showed beta decay coming from within the nucleus. And basically, he got his Nobel Prize in 1935 for studying this and the slowing down of neutrons in matter. Thank you. I'll continue this.